Hello. 6/16 talks about a parallel plate capacitor, showing the figure below, which is filled with a lossy dielectric material, with the permittivity epsilon r and conductivity of theta. The separation between these planes is the distance d, and each plane is of surface area A. This capacitor is connected to a time-varying voltage of Vt. So question A asks us to obtain an expression for IC, which is the conduction current, flowing between the plates inside the capacitor in terms of the given quantities. So here the given quantities to us are, well, the distance d, the surface area A, the epsilon and the theta, and the voltage Vt. And now you want to start here. So you know that the R is L over theta S, where S is the surface area, the conductivity, and the length from our equation sheet. From there, we know that the area is D here, theta stays, and the area is A. And from here, we can use the Ohm's law. V equals IR, thus I is equal to V over R, where I is equal to V times V over R, so A over D. Yeah, and that's the current IC flowing through the capacitors. It was easy. And B asks us to obtain an expression for ID, which is the displacement current flowing inside these capacitors. Okay, so I displacement is defined by the equation d over dt integral d dot ds, and because t is equal to epsilon e, this could be rewritten as d over dt epsilon e dot ds. From here, we know that ds, which is the surface area, is a. This can be rewritten as d over dt epsilon e a. From here, this is just equal to just the constants on the front, and d e over d, derivative of dE over dt. That's the final answer. The last question based on the expressions for part A and B, they want us to give an equivalent circuit representation for the capacitors. So for parts A, we found the expression for the conduction current. B, we have the expression for the displacement current. So C. Sorry, one sec. They want us to find the circuit representation. Okay, so they want us to give us a circuit representation for the capacitors. So we know that IC, conduction current, is proportional to the voltage, while displacement current varies as dV over dt. And we know that R is equal to D over conduction A. And we also know that capacitance is epsilon A over D. So the actual capacitance we have would look like, where this is Vt plus minus capacitance and the epsilon and the conductance in between. This can be re-represented as the parallel between R and C, the current flowing in this direction, and then plus and minus Vt. And this is the equivalent circuit. Go on to the next question. Next question just asks us to evaluate the actual values for the circuit elements and gives us these numbers for this V. Just have to plug everything in. So D, we know that the V, we know that R is equal to D over alpha, which is equal to 0.5 times 10 to the minus 2, or 2.5 times 4 times 10 to the minus 6. And this goes to 5 ohms. And C is equal to epsilon E over D, displaying values, and again is equal to 4 times 8.85 times 10 to the minus 12 times 4 times 10 to the negative 4, all over the distance, which is 0.5 times 10 to the minus 2, and this equates to 2.84 times 10 to the minus 12 Fahrenheit. Why does it Fahrenheit to F? And yeah, that was 6.16, just parallel plate capacitors with a lossy dielectric material in the middle.